Hello there, curious minds. A Chinese startup just dropped a model that beats GPT-5.5 and Gemini 3.1 Pro on coding benchmarks. And it costs 5% as much. MiniMax M3 is the first open-weight model to combine frontier coding, a million-token context window, and native multimodality, all in one package. And the open weights drop in 10 days. Let me walk you through why this matters more than you might think. MiniMax isn't a name most Western AI observers track closely, but they should. This is a company that quietly built one of the most efficient attention architectures in production. And now they've open-sourced the results. They've been operating primarily in the Chinese market, serving hundreds of millions of users through their Hailu AI platform. While Western AI companies were fighting over benchmark leads, MiniMax was quietly building infrastructure for scale, and now they're bringing that infrastructure to the open source community. M3 stands for their third-generation flagship model, but calling it a model undersells it. It's a coding agent, a multimodal reasoning engine, and a million-token context powerhouse, all distilled into a single open-weight package. Here's the part that caught my attention. MiniMax didn't just release a model and call it a day. They ran it autonomously for 12 hours straight, reproducing an entire ICLR research paper, 18 commits, 23 experimental figures, 0 human intervention. That's not a chatbot. That's a research assistant that doesn't need sleep. Let's talk about what makes M3 technically interesting, because the architecture is where the real story lives. Traditional transformer attention compares every token against every other token. That's fine for short contexts. But at 1 million tokens, the compute costs explode quadratically. MiniMax solved this with something they call MSA, MiniMax Sparse Attention. Instead of comparing every token pair, MSA pre-filters relevant KV blocks and processes only those. But here's the clever part. Instead of loading matching blocks from memory for each individual query, MSA flips the logic. It processes blocks sequentially, batching together all queries that need each block. Each block gets read from memory exactly once, in a contiguous access pattern instead of scattered jumps. The result? M3 needs just 1/20th of its predecessor's compute per token at million-token context. Input prompts process 9 times faster, responses generate 15 times faster. And the implementation runs more than 4 times faster than competing open-source alternatives. That's not an incremental improvement. That's an architectural redesign that makes million-token context actually practical. And here's what makes this different from other sparse attention approaches. Most sparse attention methods, like sliding window or local attention, sacrifice long-range dependencies for speed. MSA doesn't. By pre-filtering relevant blocks and processing them sequentially, it preserves the ability to attend to distant tokens while cutting the compute cost dramatically. It's not a compromise, it's a genuine optimization. Now, let's talk numbers. And I want to be careful here. These are mostly MiniMax's own benchmarks, so take them with appropriate skepticism. But the picture they paint is striking. On SWE-Bench Pro, the hardest software engineering benchmark, M3 scores 59%. That's ahead of GPT-5.5 and Gemini 3.1 Pro, and approaching Opus 4.7 quotes 64.3. For an open-weight model, that's remarkable. Terminal Bench 2.1, 66%. MCP Atlas, 74.2. And here's where it gets really interesting. BrowseComp, the autonomous web browsing benchmark, 83.5. That actually beats Opus 4.7, quote 79.3. Now, Anthropic has since shipped Opus 4.8, which pulls ahead on most of these. On SWE-Bench Pro, Opus 4.8 hits 69.2, 5 points clear of M3. On Terminal Bench, 74.6 versus M3 66. And on OS World, verified, the computer use benchmark Opus 4.8 reaches 83.4 compared to M3 70. So M3 isn't beating the latest frontier, but it's competitive with last generation's best, at 5% of the cost. And that changes the calculus entirely. Think about it this way. 6 months ago, to get SWE-Bench Pro performance at 59%, you'd need to pay Opus 4.7 pricing. $5 input, $25 output. Now you can get similar performance for 60 cents input, $2.40 output. That's a 20x cost reduction in 6 months. The pace of efficiency gains in this space is staggering. But benchmarks only tell part of the story. What really impressed me were the autonomous demos MiniMax ran. Demo 1, 12-hour ACLR paper replication. M3 was given a single paper, learning dynamics of LLM fine-tuning, and told to reproduce it autonomously. For nearly 12 hours, it worked without intervention. It produced 18 commits, 23 experimental figures, and successfully replicated the core findings. The multimodal capabilities parsed charts and formulas from the paper. The long context-fit paper, code, and experiment logs in a single window, and the coding and agentic capabilities drove the long horizon execution. Demo 2 is the one that really got me. M3 was tasked with optimizing a CUDA kernel, FP8 Gem, one of the most compute-intensive operations in LLM inference. It started with only a task description and a non-runnable Triton skeleton. No reference solution to copy from. Over 24 hours, M3 completed 147 benchmark submissions and 1,959 tool calls. It pushed hardware peak utilization from 7.6% to 71.3%, a 9.4 times speedup. With zero human intervention, most other tested models gave up after a few dozen attempts. M3 worked through several plateaus and didn't reach its best solution until attempt 145. That persistence, the ability to keep trying when initial approaches fail, is what separates a research tool from a production agent. Think about what this means for CUDA optimization. Normally, you'd need a GPU engineer with years of experience to manually optimize kernel performance. M3 did it autonomously in 24 hours, starting from scratch. If this generalizes, and that's a big if, it could dramatically reduce the cost of performance optimization across the entire AI infrastructure stack. And Demo 3, PostTrainBench. MiniMax gave M3 4 pre-train OMI base models and asked it to autonomously complete the full training pipeline, data synthesis, training evaluation, and iteration, within 12 hours. M3 scored 37.1, ranking third overall behind only Opus 4.7 and GPT-5.5, significantly ahead of all other models. Now let's talk about the part that changes everything for enterprise adoption. The price. Current API pricing, 3 cents per million input tokens, $1.20 per million output tokens, on fresh cash. That's the discounted launch price for the next week. Full price, 60 cents input, $2.40 output. Let that sink in. At full price, M3 is 8 to 20% the cost of leading US proprietary models. At the launch discount, it's roughly 5%. And here's the kicker. MiniMax has committed to releasing the model weights on Hugging Face and GitHub within 10 days. Open weights. Full enterprise downloading and customizability. Free of charge. Think about what that means. You can deploy M3 inside your own private cloud. No data egress. No vendor lock-in. No per token API fees after deployment. Custom prefix caching on your own hardware. A highly efficient runtime budget becomes a permanent privately owned corporate asset. For companies processing millions of tokens daily, legal firms reviewing contracts, financial institutions analyzing reports, healthcare organizations processing medical literature, the economics are transformative. At API pricing, you're looking at thousands of dollars per month. At self-hosted open-weight pricing, you're looking at hardware depreciation and electricity. The break-even point for a dedicated GPU cluster just moved from only for the largest companies to accessible to mid-size enterprises. And for developers, you can fine-tune M3 on your own data, create specialized versions for your domain, and deploy them without worrying about API rate limits or usage costs. The open-weight model turns AI from a service you rent into an asset you own. Let's put M3 in context against the models you're probably already using. Against DeepSeek V4 Pro, M3 edges ahead on SWE-Bench Pro, 59 versus 55.4. On BrowseComp, they're nearly tied, 83.5 versus 83.4. On MCP Atlas, M3 leads 74.2 to 73.6. but DeepSeek pulls slightly ahead on terminal bench 67.9 versus 66. It's genuinely close. Against GPT-5.5, M3 wins on SWE-Bench Pro and BrowseComp. GPT-5.5 likely leads on terminal bench with its codec CLI harness. But remember, GPT-5 costs 10 to 20 times more. Against Opus 4.7, M3 approaches but doesn't match it on coding benchmarks. But M3 beats Opus 4.7 on BrowseComp, and Opus 4.7 costs roughly 20 times more via API. The real comparison isn't M3 versus the latest frontier, it's M3 versus what you can get at 5% of the cost. And at that price point, the performance is extraordinary. And here's the thing about comparisons. Benchmarks are useful, but they don't capture the full picture. What matters is, can this model do the job you need it to do at a price you can afford? For many use cases, code review, documentation generation, data analysis, research assistance, M3 at 5% of the cost is a better answer than Opus 4.8 at full price. Not because it's smarter, but because it's good enough and affordable enough to deploy at scale. Now, because I'm a fox of integrity, let me be honest about what M3 isn't. First, these are largely self-reported benchmarks. MiniMax ran the evaluations on their own infrastructure. Independent verification will be important before drawing firm conclusions. We've seen this movie before. Companies announce impressive numbers. Independent testing reveals a more nuanced picture. Second, M3 doesn't beat the latest frontier models. Opus 4.8 leads on most coding benchmarks. GPT-5 likely leads on terminal tasks with its own harness. M3 is competitive with last generation, not ahead of the current one. Third, the open weights aren't released yet. MiniMax says 10 days. We've heard that before from various companies. Until the weights are actually on Hugging Face, treat the open source claim with appropriate caution. Fourth, MiniMax hasn't released training code or inference operators. This is open weights, not fully open source. There's a meaningful difference. You can inference and fine-tune, but you can't reproduce the training process from scratch. Fifth, the million token context is impressive, but most real-world applications don't need it. The practical sweet spot for most coding and analysis tasks is still 10 to 50,000 tokens. The million token capability is a proof of architecture, not necessarily a daily use feature. But even with those caveats, a model that beats GPT-5.5 on key benchmarks at 5% of the cost, that's worth paying attention to. Here's my take, curious minds. MiniMax M3 represents something we've been waiting for in the open weight ecosystem. Not just another model release, but a genuine architectural innovation. Sparse attention that makes million token context practical, paired with frontier-level coding performance at a fraction of the cost. The autonomous demos are impressive, but the real story is the pricing. When open-weight models reach frontier performance at 5% of API costs, the enterprise calculus shifts permanently. Private deployment, no vendor lock-in, full customizability, the open weights drop in 10 days. I'll be watching closely. And when they drop, I'll do a full technical breakdown, architecture deep dive, local deployment guide, and head-to-head comparisons with the models you're already using. If this was useful, you know what to do. Link in description for the deep dive. And I'll see you in the next one. That's all for today, curious minds.